Okay, good morning everyone. My name is Kari Luojus. I work here at the FMI at the Arctic Research Department. I was asked to be presenting a brief introduction to Copernicus and ESA climate datasets. And because of my background, I will focus more on the ESA climate datasets and ESA CCI program. Brief outline. So, like I said, I will not talk about Copernicus that much. I'll just briefly mention something about it, and I will talk about these ESA satellite-based datasets. I will talk a bit more on ESA GlobSnow. So there were some questions on snow. I decided I'll give an answer to those questions in my presentation now, and then I will introduce a few selected ESA CCI, which is projects that we have been involved with FMI. So talking about sea ice, soil moisture, and ozone. So briefly, there are several ESA projects ongoing that try to coordinate and facilitate access to different climate datasets. So, for example, this CORECLIMAX, CLIP-C, ERACLIM. There are various different projects, and I was trying to find out some information about the different ESA services providing climate datasets, and I didn't find too much. I found that, for example, GeoLand 2, they provide some climate datasets. So, for example, for LIA, FA-PAR, and F-cover. There are no cryosphere-related datasets from ESA, but there are several of those from the ESA CCI program, which is the Climate Change Initiative program of ESA. It's a program, so going to the ESA CCI, it's quite a wide program from ESA, so European Space Agency. They are focusing on these satellite-based essential climate variables. I will talk a bit more on CCI sea ice, aerosol, ozone, and soil moisture, but there's a wide range of different other variables as well, such as cloud, fire, greenhouse gases, glaciers, ice sheets, land cover, ocean color, sea level, and sea surface temperature. The common denominator for all of these datasets, these are based on satellite data. And I'll talk go into a bit more detail on this ESA U program and ESA GlobSnow project, which is coordinated by the FMI, and the project is focusing on terrestrial snow cover and trying to construct these long-term datasets on two different variables. So I'm moving on to ESA U GlobSnow. It's a project that has been started already in 2008. It started within the DO program with an initial duration of 3 years. It was extended a bit longer, and we are going into a continuation of the GlobSnow 1 into a GlobSnow 2. So it is still ongoing. We have a few more months to go with the project, and I will describe it in a bit more detail. So it's a quite a large consortium. We have most of the players from European side. So we have Austrian partners, NVO, Swiss partners, Gamma Remote Sensing, Norwegian Computing Center, and University of Bern, Meteoswiss, SAMK, and Noru. And then we have two institutes from Finland, Finnish Environment Institute and the Finnish Met Institute, which is coordinating the project. We're working on generating these long-term time series for snow extent and snow water equivalent, so two different parameters. And we are providing this data in daily, weekly, and monthly fashion. And the focus is on this climate perspective, so looking at these long-term data sets. And like it was mentioned, there's not a near real-time product which is coming, or the near real-time product is not coming in a kind of a timely fashion. So there's a delay of a couple of days in the production, because we're getting all the satellite and drone-based data we need for the generation of it. So it is a slightly delayed near real-time product that is provided. All the information, data, products are available from the website, globsnow.info. So I will discuss a little bit about these two different datasets we are producing. So for snow water equivalent, SWE, we are using passive microwave radiometers. We're able to go back in time until 1979. So we're reaching about 34 years of time series. for snow extent, we use optical data from ESA satellites. We are going back in time 17 years, so starting from 1995. The primary products are the daily datasets, so daily SWE and daily fractional snow extent. And secondary products are weekly and monthly composites, calculated from the daily products. So briefly on the snow water equivalent dataset, it is this equal area projection, E-grid, which has a spatial resolution of 25 by 25 kilometers. We are masking out the mountains, glaciers, Greenland, and focusing on the terrestrial snow cover. From this dataset, you can get the snow water equivalent estimates, snow extent, the progress of the melt zone. We are producing an estimate of an effective grain size as well, and the time series goes from the beginning of the passive microwave radiometer era, from late 79 actually. So we use a combination of satellite data and ground-based data. So we use the satellite radiometer data in combination with ground-based synop measurements to come up with a best estimate for snow water equivalent for each day. We'll probably go quite briefly here. We use simmer data from 1979 to 1987, and from 88 until present we go to SSMI and SSMIS. We used to generate the time series using ANSRE in an earlier product version, but now we are for consistency we are only using the SSMIS from 88 to present day. We are also calculating error estimates for each pixel, and the data formats we are using HDF4 and NetCDF-CF. We're currently masking out glaciers, Greenland, and mountains, but for some test users we are also releasing the mountainous information, which is however not very accurate. So the coarse resolution of the satellite data is not really suited for estimating the SWE for mountains. I already mentioned we are also calculating a statistical standard deviation for each pixel, so you get a sense of uncertainty coming along with each product. We combine the satellite-derived information with ground-based information, and there is a tendency of getting a strong signal from the weather stations if you have a dense weather station network, but when you have a sparse weather station network, for example in Russia, Siberia, the large or high impact or large portion of the signal is coming from the satellite data. So it's a variational data assimilation system which utilizes both input data. So we've been looking at the accuracy of the product. We of course use independent evaluation data, so we have the snow course information coming from Finland, Canada, Russia, and what we are seeing is that the GlobSnow approach, which is shown on the left-hand image, is doing quite a good job if we compare it with the passive satellite retrieval alone, which is the right-hand image. So the image shows you the benefit we get from utilizing the ground-based information in conjunction with the satellite data. A few words about the feasibility as a climate data report. So when we're talking about climate datasets, we're always interested in the long-term changes we see in the dataset. So basically one of the key requirements is the consistency of the dataset in a long-term time series. So for this SWE dataset, we use different sensors. So we use two different families. So we use the simmer data and we use the SSMIS family, which actually consists of numerous satellites, and we utilize 5 different satellites from that family. And a key question is whether the kind of a signal we see from the time series is it coming from the changes in the sensor characteristics, or is it a real change in the snow cover we're seeing. And basically, well, briefly, I'll go to the next slide. We compared the retrieval accuracy for the different years independently, and we actually see that the assimilation approach is helping us to get a pretty consistent retrieval accuracy throughout the whole period. So we're doing quite a good job in that aspect. Okay, I will briefly present the snow extent dataset, which is coming from the optical sensors. So we're using ESA ATSR2 and AATSR to generate the snow fraction of snow extent for Northern Hemisphere. It utilizes a method which is developed originally for the boreal forest zone, and it has been developed to function throughout the Northern Hemisphere. And there's also a new cloud detection algorithm that was developed for this product. So it is a big challenge for optical instruments to try to classify between clouds and snow cover during the winter season, and that's a challenge. And we've been able to come up with a quite satisfactory cloud retrieval algorithm. We're also providing uncertainty estimates for each retrieval, and the data production is also running at the FMI. Due to the sensor characteristics, since we use the ATSR2 and AATSR, we're getting a pretty narrow swath. So basically it's a 500 kilometers swath. So if you look at the top image, you see that the day coverage is not complete. So we are having quite a large portions of the data coming or missing for each day. So when we calculate the 7-day and monthly composites, we get a full picture. And of course you can see, for example, on the top image, you can see the obstruction coming from clouds, and you're not getting a full daily image out of from this sensor. I will not go into the details of the retrieval algorithm. What I will say is that it accounts for the forest canopy, so it tries to improve the retrievals over forested regions, and it is doing quite a good job on that. So basically, we have compared the GlobSnow product with the NASA MODIS product, which is kind of the benchmark optical snow product. And we see that the upper image shows the difference between the NASA MODIS product and the GlobSnow product. And what we can see is that when we mask out the forests, the retrieval accuracy or the retrieval is relatively similar. So basically we get, when we don't have forests, the retrieval accuracy is pretty much the same for the two different products. But when we look at the forests, we see a pretty large difference between the MODIS product and the GlobSnow product. And we are actually still carrying out further investigations, but what we think at the moment is that we are probably getting a better agreement between the GlobSnow product and the ground truth than what is seen with the NASA MODIS product. And we're also calculating the statistical uncertainty estimate for each pixel. And yeah, maybe not for the climate aspect, but as an additional product coming out is this Suomi NPP Virs-based snow extent product, which when we use that, we can get a full daily hemispherical coverage as well. And this is produced in real-time fashion. Just to give you a few examples what we can do with this, for example, GlobSnow SWE dataset. So basically what we have done is we can calculate the long-term time series, this mean and standard deviation between different years, and we can use this information to put the current snow conditions into context. So what you can see is that when we plot, for example, the current, or this is an example for 2 different years, we plot the current snow conditions that we observe, we can compare it with the long-term climate record, so we can see what is the difference between the different years. So similar to what has been done, for example, for the Arctic sea ice, so you can see the progress of the melt of the sea ice, so you can also track the hemispherical snow cover volume using this climatology. Also, what we are currently investigating is looking at the climate model simulations and comparing them with the observational-based GlobSnow dataset. So it's still under preparation. A summary: we are producing 2 long-term data series of snow cover, one on snow extent and one on snow water equivalent. I have added the links for the data, so if you're interested, you can. It doesn't require any logging in. You can download the information and use it for whatever investigations you are interested in. And there's also an FTP access if somebody's interested to get the full long-term data sets. That's possible as well. I will go briefly into a few other ESA CCI projects that FMI has been participating in. The first one is sea ice thickness CCI. So these slides are courtesy of Eero Rinne, who's been working on this. What they are doing in the sea ice CCI project is that they're trying to generate a long-term time series of sea ice concentration, so the extent of sea ice for the Arctic Ocean, and then also they're trying to generate a sea ice thickness time series using ERS-1, 2, and ENISA time series. And these are starting from late 80s and early 90s, these 2 data sets. For Arctic and Antarctic, they are providing the sea ice concentration along with uncertainty coming for each pixel, and the same is also done for the Antarctic. So in addition to getting this parameter out, you're also getting an estimate of the uncertainty, which is a key requirement for the CCI program to get a grip of the uncertainty of these estimates. This is an example of monthly sea ice thickness, which are composites of ENVISAT radar altimetry sensor, and this is just an example of the information that you can or that's generated within the CCI project. Okay, that was a brief introduction to the sea ice project. I will go on to CCI Soil Moisture project. So basically, it's a project which is started a couple of years ago. They have an objective to produce a complete, consistent global soil moisture data record based on active and passive microwave sensors. So they use the ESA ERS-1 and ERS-2 sensors, and in conjunction with METOP-A for active observations, and using the passive microwave coarse resolution data, they are able to go to early 80s. And this is something that FMI is participating in validation of the datasets in the boreal forest regions. A few words about the ESA Ozone CCI project. The work is, or the main focus of this project is to create the state-of-the-art homogenized dataset on ozone profiles based on ENVISAT, ODIN, and SKISAT satellite data records. So I will not spend too much time on this, just to mention that there are harmonized datasets on ozone profiles that are provided, and they are, I think, daily data sets and also level 3 monthly mean ozone profile datasets are provided. The datasets start from 2001 and goes all the way to 2012, since the ENVISAT was dead after that. Dataset, it's there. The daily level or the monthly level 3 products are covering a subset of these years, 2007 and 2008. Data availability. These data, as well as the other ESA CCI data sets, are accessible through the ESA CCI web portal, and well, maybe for the ozone CCI, the address is over there, and for the other data sets, you can go to the ESA CCI website. This is an example of the data sets currently available there, and it's open access, so no registration, no password. You're able just to go there and pick up the data. Yeah, I think I will skip to the example of these datasets. So basically, these show you the monthly zonal mean profiles for ozone mixture ratio for 1 month, and basically the idea is combine the different information from the different sensors, and in that sense you're able to compare the different, the uncertainty coming from the different sensors. And they're also using ozone zoning data to estimate the accuracy of the product and validate these products. Okay, brief summary. I think I'm pretty much in schedule. Concerning ESA, Copernicus, and climate datasets, I did not find too much actual datasets that are provided by ESA. I know there are some, for example, from GeoLand 2, and that's an open question, and I guess perhaps this project will also list the different datasets that are available. At the moment, no cryosphere datasets are available from Copernicus, but from ESA there are several cryosphere datasets and several other datasets coming from the ESA CCI program, which is ongoing. Okay, I think I will end there. Thank you for your attention.
Questions to Aki?
Okay.
Yeah, you showed the product with the Northern Hemisphere tracker for the snow water equivalent volume. So are those kinds of products available somewhere online already, or is it just something that people should, use the data and
see
for themselves?
I'm not sure if we're gonna run into a demo effect, but Boll cryospherewatch.org. Let's see. Also try to. We have the. Okay, it's coming online. There are these satellite trackers. So this is showing the SWE conditions for this year from the FMI tracker, and then there's a few different trackers by the Environment Canada. So these are currently not available online. So
okay.
yes,
Yeah, thanks.
So they are produced by FMI and Environment Canada, and they are provided to the Global Cryosphere Watch website. Okay, I'm not keeping you from lunch. Do you want to conclude the session?
Other questions? Well then, thank you very much.